Why is understanding IP addressing and subnetting so vital in the world of computer networking? Well, dive into this ocean of knowledge and let's find out. Every device connected to a network, be it a massive corporate infrastructure or your home Wi-Fi, needs an IP or Internet Protocol address. This identifier allows devices to communicate with each other. Think of it as the digital equivalent of your home address, a unique location that tells others where to find you. There are two types of IP addresses you might encounter: IPv4 and IPv6. IPv4 is the old guard, a 32-bit numerical label divided into 4 octets. An example of this would be 192.168.0.1. However, with the explosion of internet-connected devices, the world started running out of these addresses, leading to the creation of IPv6. This new, shinier version uses 128 bits, allowing for a significantly larger pool of unique addresses. IPv4 addresses are further divided into 5 classes. A through E classes A, B, and C are used for host addresses, while D is reserved for multicast groups and E for experimental purposes. And what about private and public addresses, one might wonder? Well, there are specific ranges of IPv4 addresses reserved for private networks like your home or office. These aren't routable on the public internet and are used for local networks. Now, journeying into the realm of subnetting, the purpose becomes clear. Subnetting allows network administrators to divide a network into subnetworks, improving performance, security, and management. It's like partitioning a hard drive. It helps create smaller, more manageable chunks. The tool for this job is a subnet mask, a 32-bit number that divides an IP address into network and host portions. In the mask, a series of consecutive 1 bits is followed by 0 bits. The 1 bits are dedicated to the network and the 0 bits are for host addresses. Then we have CIDR, or Classless Interdomain Routing Notation. It's a way to represent IP addresses and their associated routing prefix, expressed as IP_address/prefix_length. The prefix length indicates the number of bits used for the network portion. So, why bother with subnetting? It allows for more efficient allocation of IP addresses within a network, reduces network congestion, improves performance, enhances security, and makes network management easier by breaking down large networks into smaller, more manageable segments. In summary, understanding the concepts of IP addressing and subnetting is crucial not only for network administrators but for anyone involved in designing, implementing, or troubleshooting computer networks. It's the language of the digital world. And as we become more connected, it's a language worth learning. In summary, understanding the concepts of IP addressing and subnetting is crucial not only for network administrators, but for anyone involved in designing, implementing, or troubleshooting computer networks. It's the language of the digital world, and as we become more connected, it's a language worth learning.